Hi, good day. Welcome back to our class in Chemistry 102 Laboratory. Today, we're going to prepare the common laboratory reagents. Actually, this is activity number 11, and we are going to prepare the common laboratory reagents such as the hydrochloric acid and the sodium hydroxide solution. In preparing this hydrochloric acid solution, we're going to calculate first the volume of the concentrated hydrochloric acid, that is 12 molars, and how much are we going to use of this acid in order to form a 0.1 molar hydrochloric acid solution in 500 ml solution. And in the preparation of the sodium hydroxide, we are going also to calculate the mass of the sodium hydroxide pellets to be used in making the 0.1 molar sodium hydroxide solution. So let's prepare first the hydrochloric acid solution, that is 0.1 molar. If we are going to calculate the volume of the concentrated acid, that is 12 molars, to be used in making a 0.1 molar hydrochloric acid. So, you have it there. The formula to be used is molarity of the acid times the volume of the acid used equals the molarity of the final solution of the acid times the final volume of the acid. So, because we are using a 12 molar hydrochloric acid, that will be our molarity 1. So, the formula will be M1V1 equals M2V2. So, substitute to M1 the 12 molar. For V1 that is our unknown, equals 0.1 times 500 ml. We're going to prepare only 500 ml of this solution. So, transposing, you have V1 equals 0.1 times 500 all over 12. So, if you're going to compute that, this will give us the volume as V1 equals 4.17 ml. Or we can round it off to 4.2 ml of the 12 molar hydrochloric acid. So we're going to prepare this solution. I am using here the volumetric flask. Into this, we're going to put the volume of the water that will constitute to 500 ml. Now, because the 500 ml will be deducted by 4.2 ml of the acid, so the remaining volume of the water that we're going to place into this will be 495.8 ml. So I will be measuring 495.8 ml of water. That's 100. So this is 95, approximately 95.8 or 96. And this water, this is actually the distilled water, we're going to add the calculated volume, which is 4.2 ml of the 12 molar hydrochloric acid. So this is the 12 molar hydrochloric acid, very concentrated. And we know in chemistry 1 that in mixing water and the acid, we're going to put the acid into the water. So we will use this so that the acid will not be spilled. So I'm going to use this small graduated cylinder measuring 4.2. So it must be 4.2. So I have here the 4.2 ml of the hydrochloric acid, and I'm going to add this into the 495.8 ml of water. So this is now our 0.1 molar hydrochloric acid solution. So that is how to prepare it. So we're going to place this into our reagent bottle. And we're going to shake this. So this is how to mix the water and the acid. Okay. And we will label this as 0.1 molar hydrochloric acid. Then we're done preparing our hydrochloric acid. Let's go to the preparation of the sodium hydroxide solution. Now, in preparing for the sodium hydroxide solution, we are going to weigh the mass of the sodium hydroxide pellets. And in order to know what mass are we going to use of the sodium hydroxide pellets, we have to calculate the mass. We know that the concentration of the reagent that we are going to prepare is 0.1 molar. So we have to calculate the number of grams based on the molarity. So if it is 0.1 molar, that means you have 0.1 mole per liter of solution. Now, converting the mole to grams, we have to multiply the 0.1 mole by the molecular mass of sodium hydroxide, which is 40 grams per mole. So you can cancel out the number of moles. But the liter unit there will be canceled by multiplying it with 500 ml of the water which are going to use as a solvent, so that we have 500 ml is equivalent to 0.5 of a liter. So the number of grams of the sodium hydroxide pellets will be calculated this way: 0.1 mole over 1,000 ml, converting the liter to 1,000 ml, times 40 grams per mole, so you can cancel out now the mole unit, times 500 ml, that is the amount of the water that I'm going to use to make the solution. So you can cancel out now the ml unit. So the remaining unit will be grams. So if you are going to compute that, there will be 2 grams. So I'm going to weigh 2 grams of the sodium hydroxide pellets here. And since we cannot weigh it directly on the pan because the sodium hydroxide pellets are corrosive, so we are going to use a watch glass into which we're going to place the sodium hydroxide pellets. So we have to weigh this first as an empty watch glass, get its weight, then you put the 2 grams of the sodium hydroxide pellets, then you are going to subtract the 2 masses. So this empty watch glass is 44.58 grams. 44.58 grams. Now, as calculated, we are going to use only 2 grams of the sodium hydroxide pellets. So we are going to place here. So this is how the sodium hydroxide pellets looks like. .58, so that's it. 10, 5, 4, 5, 5, 5, 3, so 1 more pellet. Just 1 more. 5, 9, 6, 5. 6. We'll just remove a little, 1 little size. Okay, that would be enough. So we have here 46.55. Okay, 46.55. Anyway, we're going to standardize this. Then with this 2 grams of the sodium hydroxide. I'm going to dissolve this into a little amount of water yet, but I am preparing already here 500 ml of the water. So I will be using this 500 ml of the water to dissolve the sodium hydroxide. But this is a little bit more. Okay. So we're going to dissolve this as fast as we can. Since the sodium hydroxide pellets are already dissolved, then we are going to transfer this into this container. And let's add our remaining volume of the water to make it 500 ml solution. So we have prepared our sodium hydroxide 0.1 molar solution. So we are going to shake this. This is how to mix well. And we will label this as the 0.1 molar sodium hydroxide solution. So this is the 0.1 molar sodium hydroxide solution. So we have prepared already the common laboratory reagents, and this time, because these are not yet standard, we are going to standardize this solution using the powder potassium hydrogen phthalate. So this is another activity that is already activity number 12 on standardization of our sodium hydroxide solution. And for the next activity, number 13, that is standardization of the hydrochloric acid solution. So that is how to prepare these two solutions. So we are done with activity number 11 on the preparation of the common laboratory reagents. Now, with those prepared laboratory reagents, we are going to standardize them, knowing actually what is the actual or exact molarity or concentration of those reagents that we have prepared. So this time, we are going to do activity number 12, that is standardization of the sodium hydroxide. So we can standardize the solution sodium hydroxide with the use of the potassium hydrogen thalate. So this is that powder that we're going to use, the potassium hydrogen thalate. So we're going to use only about 0.3 grams of this powder. So the weight of the empty Erlenmeyer flask is 85.8611 grams. 85.8611 grams. And we're going to put into this Erlenmeyer flask about 0.3 grams of the KHP. So let's add a little more to have at least 0.3 grams. So it's already 86.19. So what is the difference now? You have 86. And the weight now is 86.1954. Again, it's 86.1954 grams. So 86.1954 grams minus 85.8611 grams. So you have 3, 4, 3, 11, 3. So we have 0.33, 0.43 grams into this Erlenmeyer flask. So we have we have already here the KHP, which is 0.3343 grams. We will make 2 trials. So we'll have the second one. So this flask weighs weight of flask 2 is 93.8709. 93.8709. So we will add 0.3 to this, 0.3 to 0.5. So 9071314. So probably we're going to have 94.17. It's 94.2174 minus 93.8709. So you have 14 minus 9 is 5, and that is 6. 11 minus 4, minus 3. Okay. So we have the weight of the KHP is 0.3465 grams. So that's enough. Let's standardize our sodium hydroxide solution using this. With this KHP crystals, we are going to dissolve this in 50 ml of water. So this is our trial 1, this is our trial 2. So let's measure 50 ml of the distilled water. And shake to dissolve. We have already dissolved the KHP. Then we will add to this 2 drops of the phenolphthalein. One, two. So we're now ready to standardize our prepared sodium hydroxide solution a while ago using this KHP solution. In standardizing our sodium hydroxide solution, we're going to use the titration process. So we have to get some amount of this sodium hydroxide and we will place it into the burette. First, we're going to rinse our burette with the prepared sodium hydroxide solution. So I place here a little amount of the sodium hydroxide that we have prepared. And I'm going to use this amount of the sodium hydroxide to rinse the burette. So in rinsing the burette, just do it this way. So we're done rinsing the burette. We're now ready to standardize our sodium hydroxide solution. So position the burette this way. Then fill it with sodium hydroxide. So I have already filled the burette up to the 50 ml mark. So Let's start titrating our KHP sample. It is advisable that when you are going to titrate, you should have a white background underneath our flask so that you can see the endpoint color, which is expected to be light pink. So I'm going to use here a white background. And I will start to titrate. When you titrate, you have to see to it that you run down the liquid slowly. So while running down the liquid to the potassium hydrogen phthalate, you have also to shake the potassium hydrogen phthalate so that there is a reaction that will go on until the end point. As you have noticed, you can see a pink color each time the base drops onto the potassium hydrogen phthalate, because this is due to the indicator that we added into the potassium hydrogen phthalate. So this is the desired color that indicates the endpoint of our titration. That means the volume of the sodium hydroxide that we use in titrating this potassium hydrogen phthalate has reached its endpoint. So we are going to take note of its volume. Take note that it is light pink. It should not be dark pink. Now, how do I know that this is its endpoint? Later, I will show you that it will become overrun if it turns dark pink once one drop is added into it. But before we're going to do that, so let's take note, the volume of the sodium hydroxide that we use is 19.6 ml. So we'll write that down. So volume of the sodium hydroxide for trial 1 is 19.6. I'll show you that when I'm going to add 1 drop to this, it will turn dark pink, and that means it's overrun. That means it is over titrated. So just 1 drop. So see, this is an over-titrated of the sodium hydroxide. So it should not be like this. What I showed you a while ago was the right one, the right color. Then let's do the trial 2. Okay. Let's do the trial 2. Again, we are going to add this with 50 ml of water. Then let's dissolve the potassium hydrogen phthalate with 50 ml of water that we added by shaking. You put 2 drops of the phenolphthalein indicator. Then we're going to titrate this with the sodium hydroxide solution that we prepared. Let's take the initial reading because we have used already about 19.5 a while ago. So this time, because we got some drops of this a while ago, so our initial reading is 19.4. So initial reading for trial 2 is 19.4 ml. Okay. So let's do again the titration. Take note of the color. As I have said, it must be light pink only. Okay, so we have reached the light pink color. That means it is the end point of the titration. And let's take note of the volume of the sodium hydroxide that we have used. The final volume is 38 ml. So, what is the volume that we have used from 19.4 to 38? So, a difference of 38 minus 19.406. So, approximately, we have used 18.6 ml. So, approximately, we use 18.6 ml for trial 2. Let's put 1 drop. Instead, we can make a light pink, just 1 drop. So that we can test that it is end point. We can still do it. This is still true, but this will only give us, okay, it's only a matter of 0.05, so never mind. So we will have that final volume to be 38 ml. So this is now the end point. With the data that I have given you for the mass of the KHP, trial 1, it's 0.3343 grams. And for trial 2, it's 0.3465 grams. Then the volume of the sodium hydroxide that we use in titrating, for trial 1, it is 19.6 ml. And for trial 2, it's 18.6 ml. So we are done on the activity on the standardization of sodium hydroxide. So we will continue our standardization for hydrochloric acid. Since you have already calculated the normality or the molarity of the sodium hydroxide, we are going to use that normality of the sodium hydroxide concentration of the sodium hydroxide solution that we prepared. So for the next activity, we are going to standardize our prepared hydrochloric acid. So we are going to fill this acid burette with the acid solution that we have prepared, and we are going to titrate that acid with the sodium hydroxide that we have already standardized. So we will get some amount of the hydrochloric acid. And we're going to fill this base burette with the base that we have just standardized. In order for us to standardize this hydrochloric acid solution that we prepared, we have to use 25 ml of the acid. So we're going to run down 25 ml into these flasks. So one flask will be filled with 25 ml of the hydrochloric acid that we have prepared. And we will also fill the second flask with the 25 ml acid solution. So we have here two flasks filled with 25 ml of the hydrochloric acid solution that we have prepared. Then to each flask, we're going to add this with 25 ml of distilled water. Then we will add 2 drops of the phenolphthalein indicator to each flask. One, two. 1, 2. Now, what is the purpose of adding the phenolphthalein indicator? We know that the phenolphthalein will turn into pink or purple once the solution becomes basic. But the phenolphthalein under the acid medium, it is colorless, white or colorless. So we will have the first trial. We're now ready to titrate this with the base, and this base has been computed its normality as we standardized this a while ago. So let's start. While titrating, we're going to shake the flask containing the hydrochloric acid solution until such time that we can produce a permanent light pink color. So we have here formed the permanent light pink color. Even if you are going to shake it, it will not disappear anymore. So let's try to check how many ml of the sodium hydroxide have we used in titrating the acid. So we have used 21.9 ml of the sodium hydroxide. 21.9 ml of the sodium hydroxide. Okay, this is for trial 1. And we will have the second trial. We will titrate this using the sodium hydroxide that we have already standardized. And our initial reading for the sodium hydroxide is, let's take it as 22 ml. So initial reading, volume reading is 22 ml. Okay. So we have already titrated this and reached the light pink permanent color. That means it's already the end point in titration. So we will take note of the volume of the sodium hydroxide that we have used. Initially, it was at 22 ml, and here it is 44.3 ml. So 44.3 ml is the final reading. So volume final is 44.3 ml. So what is the volume used of the sodium hydroxide? Is the difference between the two. So it's 44.3 minus 22. So you have 0.3, so it's 22.3 ml. It's 22.3 ml. So with the results that we have obtained in standardizing our hydrochloric acid, so we will use that data and filling up the table in your lab guide. So look at your table, look at the table there. You have the volume of hydrochloric acid used. We used 25 ml for trial 1 as well as 25 ml for trial 2. Then the volume of base used for trial 1, we have recorded that data. We have 21.9 ml. 21.9 ml. And for trial 2, it's 22.3 ml. So you write it here, 22.3 ml. So you can now solve for the normality of the hydrochloric acid and the normality of the base. Since you have already computed this a while ago, you use that as the normality of the base, and you can solve already the normality of the hydrochloric acid. So that would be all for today. We have performed actually 3 activities. Anyway, these 3 activities are related to each other because once you have prepared the reagents, it would be advisable to standardize them immediately. Now, we have done the 3 activities. 1, we have the preparation of the common laboratory reagents. That's activity number 11. Then, number 12 is standardization of the sodium hydroxide. And number 13 is the activity on the standardization of the hydrochloric acid. Now, although we have done this in one setting, I would like you to make 3 reports, separate reports. for these three activities. One report for the activity on preparation of the common laboratory reagents, one report for the standardization of the sodium hydroxide, and one report for the standardization of the hydrochloric acid. Anyway, they are only short activities. And kindly submit your reports next week. By the way, as I have said weeks ago, that the activities and the exercises for the lecture are to be submitted 1 week before the final exam. So I am expecting the experiment reports, the quizzes in the laboratory, and the exercises in the lecture are to be submitted next week. So I will be giving a schedule on when you are going to submit this in the laboratory counter next week. And I'm going to give you a performance task which can be done in 2 to 3 days. That is on the finding or the determination of the pH of the different liquids. I will be sending you the procedure next meeting. So that would be all. This is your teacher, Professor Nisitas Ruiz of Holy Name University.